Hello everyone. Welcome to Brain Blitz Audios. In this episode of NEET preparation, we'll be looking at previous year questions of medical entrance examinations in India. We'll be looking at the physics syllabus of grade 11 CBSE. The first chapter in exams that we deal with is units and measurements. Let's look at our first question. The dimensions of Planck's constant are ml raised to minus 3, t raised to minus 1, and there are 3 other options. We need to find out which of these is the right option. So let's start calculating it. So Planck's constant, or h, is found in the formula E is equal to h nu. We can rewrite it as h is equal to E by nu, where h is the Planck's constant, E is energy, and nu is frequency. So the dimensions of the Planck's constant will be equal to the dimensions of E divided by the dimensions of nu. So energy's dimensions are m L square t power minus 2. So that is force into area. So this is the dimensions for energy. And then divided by the dimensions of frequency. Frequency is 1 by t. So the dimensions will be t raised to minus 1. So therefore, the dimensions of h will be m L square t power minus 1, because it will become t power minus 2 plus 1. Minus, when going up, becomes plus. So that becomes t of minus 1. So the dimensions of h is ml square t power minus 1. So therefore, option D is the right answer. So that contains m, L square, and t power minus 1. Let's look at our next question. This is also a question on dimensional formula. The dimensional formula of magnetic flux is one of the following, and we need to find out which of it is the right formula. So in order to calculate magnetic flux's dimensional formula, we'll use the formula force is equal to BQV, where F is force, B is magnetic field, Q is charge, and V is velocity. So since magnetic field is equal to phi by A, we'll rewrite the equation as F is equal to phi by A QV, where phi is our target quantity, magnetic flux, and A is the surface area. So now let's write this formula in terms of magnetic flux. So we have magnetic flux on the left-hand side. So area comes to the numerator, so that is FA. Q and V are on the numerator, so they go down to the denominator. So phi is equal to FA divided by QV. Now let's write out the dimensional formulas of all of those quantities. So the dimensional formula for magnetic flux. So F has the directional formula mLt raised to minus 2, mass times acceleration. And A, surface area, will be L square. L into L is A. Divided by Q can be expressed as IT, that is current into time. So current has ampere as its dimension, and then there's time. So that's the dimension of charge. And then V, velocity, is distance by time, so LT raised to minus 1. So on simplifying the numerator and the denominator, we'll get ml cubed t raised to minus 2 divided by AL, because t raised to 1 minus 1 becomes t raised to 0, which is 1, no dimension. So now we can divide L cubed by L. So L raised to 3 minus 1, that becomes L squared. And A1 by A becomes A raised to minus 1. So our dimensional formula for magnetic flux is M L squared A raised to minus 1 T raised to minus 2. This is our final dimensional formula. So when we look at our options, we find that option B is the right option. It has M, it has L squared, it has T raised to minus 2, and it has A raised to minus 1, which are the components in the dimensional formula of magnetic flux. Option B is the right answer. Now let's look at our third question. The dimensional formula of the constant A in Vander Waal's gas equation, P plus A by V squared times V minus B is equal to RT, is one of the following. So how do you find a dimensional formula for a constant? Because if you've studied units and measurements, you know that constants do not have dimensions. Well, some do. If we're adding a constant to a particular dimensional quantity, we have the following rule. For two quantities to be added, they should have the exact same dimension. So we don't need to look at these parts, but let's look at this bracket, P plus A by V squared. So since this is the true gas equation, we can write that the dimensions of A by V squared will be equal to the dimensions of P, that is pressure. P here stands for pressure. And let's write it down. So A is the constant whose dimension we need to find. And V is volume, which is L cubed. And since we have V squared, so we'll have L cubed the whole square, which is equal to the dimension formula of pressure is M L raised to minus 1 T raised to minus 2. Force by area. So you get M L raised to minus 1 T raised to minus 2. On further calculation, you'll get formula of A divided by L raised to 6 is equal to M L raised to minus 1 T raised to minus 2, because A raised to M whole raised to N is equal to A raised to Mn. That is applied to L. And now we take L raised to 6 to the right hand side. So basically we have A is equal to M L raised to minus 1 T raised to minus 2, and then L raised to 6. So now it'll be L raised to minus 1 plus 6. 6 minus 1 is 5. So we have L raised to 5. So the formula for the constant A in Vander Waals gas equation is m L raised to 5 T raised to minus 2. That is our formula. So on looking at our options, we find that option D is the right answer because it has the right quantities, m, L raised to 5, and T raised to minus 2. Our next question. What is the dimensional formula of gravitational constant? So where have we used gravitational constant? In the formula for gravitational force, which is F is equal to G M M divided by L squared. L is similar to the radius because both are the same thing, length. So now we can write this in terms of G as G is equal to F L squared divided by M. So now let's write the dimensional formulae of the components on the right-hand side. So force, it'll be mlt power minus 2 mass times acceleration, and then there's L squared divided by m squared. So in the numerator, what we'll get is m L cube and t raised to minus 2 divided by m squared. So it'll be m raised to 1 minus 2 because 2 is in the denominator. 1 by m squared will be equal to m raised to minus 2. So then the final formula for the universal gravitational constant is m raised to minus 1 L cube T raised to minus 2. This is the dimensional formula for universal gravitational constant. And when you look at the following options, we find that option C is the right answer. Our next question. Which of the following pairs does not have similar dimensions? Tension and surface tension, stress and pressure, Planck's constant and angular momentum, angle and strain. Let's look at each of our options one by one. So angle has no dimensions. Similarly, strain also has no dimensions. So they are similar, which makes option D incorrect. What about option C? The dimensions of H and angular momentum is equal to m L squared T power minus 1. So these are similar, which makes option C incorrect. What about option B? Stress is equal to pressure because they share the same formula. Force divided by area. So basically, m L raised to minus 1, T raised to minus 2. Both have the same dimensional formula. So they are similar, which makes option B incorrect. The right answer is option A, tension and surface tension. Although they look similar, tension has the dimensions of force, which is ml T power minus 2, while surface tension has the dimensions of force per unit length, which has the dimensions m, t power minus 2. So as you can see, both are different. So that means option A is the right answer because these are not the same. Tension is not same as surface tension. Now we have our final question. The length and breadth of a metal sheet are 3.124 meters and 3.002 meters, respectively. The area of this sheet up to 4 correct significant figures is 9.378, 9.37, 9.378248, or 9.3782 meters square. So first things first, area is length into breadth. So that is 3.124 times 3.002. So in order to make our calculation simpler, I just removed the decimal point and started multiplying here. So 8, 2 times 2 is 4, 1 times 2 is 2, 3 times 2 is 6. And then since there are 2 zeros, all of the 4 will be zeros. And then 4 times 3 is 12. 2 times 3 is 6. 6 plus 1 is 7. 1 times 3 is 3. And 3 times 3 is 9. On adding, we'll get 8, 4, 2, 8, 7, 3, 9. And on putting the decimals, we'll get 9.378248 meters square. So that is the total area. But we want the answer up to 4 correct significant figures. So we only need 4 figures which are significant. So we'll have to start approximation from the other end. So the last 2 digits are 4, 8. So as you can see, 8 is greater than 5. So the 4 changes to 5 on approximation. So 9.37825 meters square. And then the digit which is previous to 5 is 2, and 2 is even, so it stays the same. So that is 9.3782 meters square. And since 2 is less than 5, we'll get 9.378 meters square. The 8 doesn't change. So the final area is 9.378 meters square. This has the correct significant figures 1, 2, 3, 4, and it also is the right amount of area. So the right answer is option A, 9.378 meters square. So that concludes this episode of NEET preparation. We hope that you found this video interesting and informative about how to solve questions in medical entrance examinations. For more of our useful content, please visit our YouTube channel, Brain Blitz Audios, and subscribe to our channel. We'll be back with more useful and interesting content such as learner words, stories, mind maps, NEET preparation, CBSE board exam, etc. So until then, take care, stay safe, bye-bye for now.